Hello, and welcome to the GLOBE program's Great Global Investigation of Climate. I'm Professor Todd Ellis, an atmospheric scientist at the State University of New York College at Oneonta. I'm also the incoming Education and Outreach Lead for the NASA CloudSat mission, a mission which studies the clouds and their effects on the Earth's climate. And I'm very pleased to be with you today because I've been chosen to be one of your guides as you answer a very important question. What is your climate? But before we begin, it's important to be clear on what we mean by climate. You see, weather and climate are both very important and very often misunderstood concepts because they're both related and very different. Let's start with weather. Weather is often defined as the state of the atmosphere at any given moment in time. If you take a look out your window right now, you're observing weather. And when you go out to take your atmospheric protocol measurements at solar noon, things like temperature, precipitation, cloud cover, etc., these are all observations of weather, the state of the atmosphere at that time. Climate, however, can't be defined by any one measurement. Instead, climate is considered the long-term average of atmospheric conditions, as well as the record high and low values for each of those variables. In order to know climate, a scientist would want to have at least 30 years of data before they could be sure they could answer questions like, what is the average temperature at your location? How often does it precipitate on average? Or what was the record precipitation that you ever received? But like I said, weather and climate are related. It is our observations of weather taken the same way at the same times every day that determine our climate. It is our climate that lets us know whether or not weather that's coming in the sky is unusual. In fact, it's important to remember that just because the climate says something is not typical doesn't mean it can't happen. Just because it's never been 40 degrees Celsius where you live doesn't mean someday it may not be 40 degrees Celsius. And in fact, if it were, it would be part of the climate record. Now, you might have noticed that I've been focusing a lot on temperature and precipitation. I've been doing that deliberately because temperature and precipitation are the primary atmospheric protocols that we monitor to determine climate. They're the primary atmospheric players that help us understand the kinds of plants and animals that can grow in your location. Plus, these are the variables that have been measured for the longest time and by the most reliable instruments. In fact, we've had observations from crude thermometers for hundreds of years, and people have observed precipitation since they could see. But it's only been since the late 1800s that we've been able to produce instruments that measured these variables precisely enough that we felt comfortable that everybody could make the measurement the same way each time. And only then could we start building our years of data necessary to understand climate. And that is the challenge that we face during the Great Global Investigation of Climate as well. You see, in order for us to examine the role of precipitation and temperature in determining the climate where we live, we have to be careful about how we make our observations. Every observation has to exactly follow the protocol, or it can't be compared to anyone else's. It can't even be compared to other measurements you make. Plus, if you don't upload those data, then we can't keep a long enough record to start to turn weather observations into climate. And nobody else will be able to compare their climate to yours. So before you start this investigation, I encourage you to go outside to your atmospheric site and make sure that it's set up exactly the way it's supposed to be. And even if you use an automated weather station to observe precipitation, I encourage each and every one of you to go out and get one of these. This is a rain gauge, and remains to this day the climate scientists' gold standard for precipitation. This never breaks, and we have used this for hundreds of years to determine climate. I think you would be well served to do so as well. But more importantly than making sure that you take the data properly and you enter it properly, I challenge you to think. A good scientist thinks about what their data mean and asks questions of themselves and their classmates about those data and why they take the measurements the way they do. And by asking those questions, you can often come up with some questions of your own that become good topics for your own research. Let me offer you just a couple to get you started. Some questions you might consider would be, what is the average precipitation you receive during your warmest and your coldest months? And how do they compare to the total precipitation you receive every year? What is the average temperature that you measured over the 2 weeks of this period? And do they compare with what's typical of your climate? If you do use an automated weather station at your school, what happens if you put a rain gauge out as well? Do they measure the same precipitation? And what would happen if instead of putting your atmospheric site in the middle of a grassy place, it were placed in the middle of a parking lot? Or vice versa? Or somebody decided to put a building next to the place where you'd been measuring temperature for hundreds of years? These are the same questions that climate scientists ask themselves every day. And all of these questions are going to help you answer the ultimate question. What is your climate? When you've got to the end of this period, I encourage you to please join us as we host a live webinar with other members of the Globe community from around the world on Tuesday, March 22nd. We'll be sharing our answers to these and other questions and learning about our climate as we celebrate World Water Day. And if you can't tune in to join us at that time, don't worry. We'll record the event and you can watch it at a time that suits your needs. But until then, go outside, take those data, and above all, think. Think about their impact on determining what is your climate. Good luck. Thanks.